Here we have a problem on integration. That is, we have to evaluate the definite integral over here. Okay, now first let me start working on this one with the indefinite integral. That is, without limits, I am going to evaluate this integration. So once I'm done with the evaluation, I can plug in the limits. That is, lower limit 3, upper limit 6. Okay, now let me start with the indefinite integral. That is 1 over 49 positive x negative 3 the whole square times dx. Let me write over here. Okay, integral 1 over, I'm going to write this 49 as 7 square positive x negative 3 the whole square dx. Okay, now let me continue a formula and integration, that is integral 1 over a square positive x square times dx. Whenever we integrate a function in this form, 1 over a square positive x square, where a is a constant, its integration is 1 over a times arc tangent x over a positive c. Okay, now let me consider the stuff we have over here. It's almost in this form. So at the place of a, we have the constant 7. At the place of the variable x, we have an expression x negative 3 the whole square. If I want to use the formula we discussed over here, so the variable has to be squared, a single variable has to be squared over here, but instead of a single variable, an expression, linear expression has been squared. So now we have to get a single variable over here at the place of x negative 3. What do we have to do for that? We have to go with u substitution for that. That is, we have to substitute a new variable u for this x negative 3. Okay, let me do it. So let u equals to x negative 3. Since I have substituted a new variable u, I have to get the complete integration in terms of the new variable u. When I get the complete integration in terms of the new variable u, at the place of dx, I must be getting du. So if I want to get du at the place of dx, what should I do with this u? I have to find the derivative. Actually, we have the original integration in the variable x. So we have to find derivative on both sides here with respect to x. When I find derivative of this u with respect to x, I am getting du over dx. Here, when I find derivative of this x with respect to x is just 1. The derivative of the constant negative 3 is 0. Okay, now to get rid of the denominator dx over here, I have to multiply both sides by dx. Okay, let me do it. When I do so, this dx will cancel out. I'm getting du equals to 1 times dx is dx. Okay, now let me continue the integration over here. Integral 1 over 7 square positive. Now for this x negative 3, we can plug in u. Then this x negative 3 the whole square will become u square. And for this dx, we can plug in du. Okay, now let's consider this particular part of the integration over here. It's exactly in the form of 1 over a square positive x square. Now we can use the formula over here to get the result of this integration. So for that, what we have to do is we have to write 1 over a. Instead of a, we have 7. So 1 over 7. Arc tangent x over a. For x, we have u, and for a, we have 7. Okay, now I got the result of the indefinite integral over here, but we got the result over here in terms of the new variable u. So it has to be replaced by the original stuff, that is x negative 3. Okay, now let me do it. 1 over 7 times arc tangent x negative 3 over 7. Okay, now I got the result of this indefinite integral in the original variable x over here. Okay, now let me erase the other stuff and continue the problem. Okay, let's continue. Already we got the result of the integration, that is 1 over 7 times r tangent of x negative 3 over 7. Actually, this is the result we got it for the indefinite integral, but the given integral is a definite integral with the limits 3 and 6. Now what we can do is we can plug in the limits of the lower limit 3, upper limit 6 for the result of the integration, that is 3 to 6. Okay, now what I have to do is in this result for x, I have to plug in the upper limit 6. Then I'm getting 1 over 7 times arc tangent of 6 negative 3 over 7. Now I have to take negative sign. In the same result, I have to plug in the lower limit 3 for x over here. Then I'm getting 1 over 7 times arc tangent of 3 negative 3 over 7. Okay, here 1 over 7 times arc tangent of 6 negative 3 is just 3 over 7 negative 1 over 7 times arc tangent of 3 negative 3 is 0. 0 divided by 7 is 0. Okay, already we know that the value of arc tangent of 0 is 0. So the value of this stuff is 0. 0 multiplied by 1 over 7 is also 0. So finally we get 1 over 7 times arc tangent of 3 over 7. So this is the evaluation of the given definite integral.